Hello, mathematicians. Welcome to day 3 of lesson 23, Understanding Fraction Multiplication. This is the third lesson for the week. So here is our ideas about fraction multiplication. It should be getting even easier. Day 3. First, we're going to draw a model to show 5 times 2, 6, then write the product. So grab your whiteboard and give it a go. You can push pause and see and then check in. Or you can do it with me. We need 5, 2, 6. Okay, I'm going to go ahead and do area model. So I need 5 models because I'm going to need 5 of 2, 6. And I'm cutting into 6s, which means 5 cuts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Get a different color to shade in. 1, 6, 2, 6, 1, 6, 2, 6, 1, 6. All right, beautiful. Then write the product. Well, 2, 6, 2, 6, 2, 6, 4, 6, 6, 8, 10. Okay, so we've got 10, 6 is the product, or 10 divided by 6 is 1 and 4, 6, which is equivalent to 1 and 2/3, which is equivalent to, decimal friends, I agree, 1 and 66 hundredths. It is a repeater. All of those answers are correct for the product of 5 times 2, 6. On page 499, let's analyze how 3 times 3, 6 is the same as 9 times 1, 6. What do you think? Yep, so this one would be 3 times 3, 6 would be 9, 6. This one would be 9, 1, 6s would be 9, 6. How are they the same? Because I guess you could say, okay, they have the same answer. I guess you could also say 3, 6 plus 3, 6 plus 3, 6 is equal to, and then you could do 9 of these. Okay, that would take a while, but you could go all the way to 9 of them. I'll put dot, dot, dot in a really messy way. That means it goes on for 9 of them. You can write them out if you like. That is how they are the same. Kind of like 3 times 3 is the same as 9 times 1. Number 2 on page 499, Violet solves 4 times 7/10 as shown. What does she do wrong? Well, already I'm kind of wondering because it says 4 7/10. She just has one hop. That seems odd. So if it's 4 7/10, it seems like she should have 1 7/10 and then count the second. So what does she do? Oh, she's doing 1, 2, 3. I think I know what she's doing. I agree with what you're thinking. She's thinking that there's 4 tenths there. So that's really like 1 times 4 tenths, but starting at 7/10. So yeah, she's a little bit confused. So what did she do wrong? She started at 7/10, and she also, so she started at 7/10, which is odd. But I suppose if you just would have put that one in there, you know, that could possibly happen. But then she's also not jumping. Then she jumped 4 tenths, not 4 7/10. Yeah, so that's what she did. Alrighty, because the answer really should be 28 tenths, which is going to be beyond here, right? Because 4 times 7 is 28. 28 tenths. I wonder if that's going to be the next problem to say fix it. Let's see. Nope. Anders triples a recipe and needs 3/2 cups of flour. He has 1/2 cup measuring cup. How many times does he fill the measuring cup with flour? Make a drawing and write a multiplication equation to model the situation. Okay, so this is about flour. Anders triples a recipe and needs 3/2 cups of flour. He has a 1/2 cup measuring cup. Okay, how many times does he need to fill it? Make a drawing. All right, it just feels like it should be like a big, huge cup thing. Maybe I should have made it more like a cup. He has a 1/2 cup measuring cup. How many times does he need to fill it to get to 3/2? I think I just, so that is 1/2, right? And that is 1/2, and that is 1/2. And that's really how big the cup is 1/2. How many times does he fill it, the measuring cup, with flour? So that would be 1/2 plus 1/2 plus 1/2 equals 3/2. 3 times. How many times? 3. Make a drawing and write a multiplication equation. Oh, we need a multiplication equation. Don't have that. I got addition, which we can fix that. How about with a happy color green? If I was to change that to multiplication, it would be, yep, I agree. 3 times 1/2 will equal 3/2. Yeah, 3 1/2. Alrighty, very nice. Joaquin runs 4/5 of a mile each day on Monday, Wednesday, and Friday. How many miles does he run in all? Monday, Wednesday, Friday. Describe 2 methods you could use to solve the problem 3 times 4/5. Well, I think that I would do, describe 2 methods. And we don't even have to do it. We just write it. Maybe we do that later. Okay, so obviously area model and then number line. And you could also just say multiply, because we are getting pretty good at these now. So I'll put that as another choice. Yeah, multiply the fractions. Write a different multiplication problem with the same product as 3 times 4/5. Use 1/5 instead of 4/5. Okay, so it's going to be something times 1/5 equals, alrighty, so up here it's 3 times 4/5, which we know would be 12/5. So that tells us right there, how many fifths do we need? 12 equals 12/5. Interesting. Allison is starting to run each day. She runs 1/5 of a mile on all 7 days this week. Okay, that's not very far. Quarter of a mile is like 1 lap on the track. I think that you guys can run farther than that, but that's just beside the point. Okay, so this is Allison. She's learning to run. That's okay. 1/5 of a mile on all 7 days this week. Joaquin and Allison each wanted to run at least 2 miles during the week. Do they? They each wanted to run. So Allison wanted to do 2. Joaquin wanted to do 2. Use a drawing or words to explain how you know. Do they? Well, we got 12/5 right here. I guess use a drawing or words. Oh, you can use words. I think I might use words. Okay, because 12/5 equals, right, 12 divided by 5 is going to be 2, and it's already over 2. We know we went over 2 miles because 10/5 is 2, right? But that's going to be 2/5. For Joaquin, I could just add the word miles in there because that would be accurate right there. Which meets the 2-mile rule. Okay, I'll move the picture so you can see that if you are using that. Hide this. Okay, and then we got to do, and then Allison, let's see, Allison, let me type please. Allison, she does 1/5, 7 times 1/5. Runs 7 times 1/5, which equals 7 1/5 is 7/5. 7/5, which is not going to make it, right? Because to get a fifth, 5/5 plus 5/5 is 10/5, okay? Which does not meet the 2-mile goal. Good try, Allison. Joaquin, you did it. You were close. So she needs 3/5 more of a mile. Use a drawing or words to explain how you know. So maybe you drew a picture. That would show too how one gets there and the other one not quite. All right, next one, math journal. How are 4 times 2 6 and 8 times 1 6 the same? Use models or words to show how you know. Dun, 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 dun. Okay, so, all right, I'll number line one because I haven't done too many number line examples. And let's see, 1 and 2, they need to be cut into 6s. Okay, that's an annoying little thing there. So 5 cuts, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so the first one we will do blue, 4, 2 6s. So it's going to show 4 ups, and they're all going to be 2 6s. Okay, so there's 2 of them. 1, 2, 3, 4. Gets us right there. So if it's equivalent, we should get to the same way, just a different color. So that's going to be 1 and 2 6 or 8 6s. All right. So that's the first one. 4 and 2 6s in blue. And then I'm going to do the next one in pink. 8 1 6s. Okay. So maybe I can do little hops. 1, 2, 3, 4, 5, 6, 7, 8. Also gets to be, let's put it up the top, 8 6. All right, that picture shows it. 8 1 6s and 4 2 6s. Equivalent, page 500. All right, mathematicians, that is the main work for the week. So you get to, let's see, do you have some pages to do yourself? I guess that's it. You're ready for the quiz. You can give the quiz a go or do it tomorrow. And excellent work. Bye, mathematicians.